Hey everybody, welcome back. Today we're going to look at a couple different methods here to calculate and sketch the following curve. Again, using a table of values, you can do this by obtaining a table of values. So what we do is we plug our values into the equation to get the y values. So we take this and we plug this in, and we obtain the y value. So I'll show you one sample calculation of what I mean by that. Okay, so one sample calculation. Again, I only need to see one calculation. So I plug in, so we'll plug in -1 here. First x value that we see in our list. I'm going to show you a couple ways to do this and using technology to help you. So -1 squared is 1. So this thing out becomes 1. -6 times -1 is -6 plus 10. So we add these together and we get 3. So the value here is 3. Okay? And we do the same thing through. 0 would give you 10. I'm just doing these in my head now, right? Okay, and 3, so 3 squared would be 9, multiplied by negative would be -9. 6 times 3 would be 18, 18 plus 10. 18 plus 10 would give you 28, so it would be 19. Put a 6 in here. 6 squared is 36, make it negative. 6 times 6 is 36. So 36, subtract 36 is 0, plus 10 would be 10. You notice you see a pattern's come back down there. If it was 7, put a 7 in, you get -49, right? 7 squared, and then make it -49. 6 times 7 is 42. 42, subtract 49 is -7. -7 plus 10 is 3. And you're going to see, you see that there's I've done this purposely, but you see there's a pattern here. 3, 10, 19, back down to 10 and 3. Okay, and there's a reason for that. I'm going to show you that in a minute with the table of values that I created. But I'm going to show you how to do that on your graphing technology, your TI-84. So remember, when you get a graph calculator, you want to clear it. Okay, if you can't clear it, just turn it off. Again, but second function plus 7, 1, 2. And your RAM is cleared. Now we're going to go up the graph, so we go y equals. Putting negative, remember the negative has to be the bottom here. X squared plus 6x plus 10. Okay. When we graph this, here's our graph. I want to make it a little bigger so we can see the maximum value there. So we got to make our y up a little bigger. I'll make it 25. Yeah, it's better now. We can see it. All right. So we're going to talk about this in more depth, of course, and we've already done it in some of the other videos. There's your sketch, but to get the table of values quickly, just hit second function graph, so it gives you the table, and you can get these values here, right? So -1 and 3, 0 and 10, 1 and 15, 2 and 18, 3 and 19, 4 and 18, 5 and 15, 6 and 10, 7 and 3. So I did that purposely. We take a few values out, which I gave you that we plugged in the x, and you can see that. Okay? So, we'll graph that now. So I'm going to graph that. There's also some other piece of information we need for doing by hand, like if we didn't have the graphic technology. Find the vertex, right? So there's a couple ways you can do the vertex. You can pick any two values of x here that have the same value of y, and that will work. And that's called using the axis of symmetry. The axis of symmetry, you can use any two x values as long as they have the same y value. So right here I use -1 and 7. They add together gives me 6 divided by 2 is 3. Again, I can use 0 and 6. Use 0 and 6. Still going to be the same thing, right? So just any two x values that have the same y value will be symmetrical. All right? And you get the corresponding y value. Well, we have it here already. This is the vertex actually. Right, but if you didn't know that, which is fine, right? You don't know that until you graph it. So what we do is you take this and plug it in to the original equation, like I mentioned, right? Okay. And before that, another way to do it, say you don't have two x values, they're the same, but you have your equation, remember, this form takes on the form of a x squared plus bx plus c. So that means that the a value is -1, the b value is 6, and the c value is 10. So another method is using x equal to, and we did it up here, I'm going to grab that. And remember, another way to find the vertex is using minus b over 2a. So our b value here is 6, and our a value is -1. So that would give us a -6 over -2. So that would give us, I'm going to get my fraction there, sorry. That gives us -6 over -2, which would equal +3 for our x value. So that's just another way to find it. I'm just showing another way to find the x value, and this will work all the time as long as you have the equation in standard form. All right, and remember to calculate that corresponding y value. To calculate the corresponding y value, just put that value in for x, 3, 3. So we plug it in, and we get -9 plus 18 plus 10. So that is -19, or +19, sorry. Which we knew anyway, it was given up here, but again, that might not always be the case, so you might have to find it. Okay? It says identify the y-intercept. The y-intercept is easily identified. Remember, again, if it's in this form, and I'll just put it up there just in case. Remember, if it's in this form, remember, if you look for the x-intercept, you let x equals 0 if you're finding the y-intercept. Okay. So we just plug in zeros anytime we see x. So it'll be a 0. And that'll be a 0. Again, as you get better at this, you're like, oh, sir, it's just 10. Perfect, that's fine. But again, in case it's not in this standard form, that'll be just 0 plus 0 plus 0. And that'll be 10. Okay. So those are some points here. So remember, this gave us the vertex we just figured out before. The vertex is going to be 3 and 19. Oh, 3 and 19. Touchy sometimes, I apologize. 3 and 19. Okay. And then we'll graph it. So a couple ways you can just plot these 4 points and draw a nice curve through, and that's how I'm going to do it on Desmos to show you. So we got our Desmos program. I don't need to save that, so start a new graph. There we go, Desmos. And we'll graph these points. The first point we had was -1, 3, wasn't it? And then we had 0 and 10. A little bigger so you can see. And then we had 3 and 19. They wrote. And we're coming back down. We have 6 and 10. And then back down we had 7 and 3. And then we just draw a nice curve through. Okay? So draw the nice curve through. I'm just going to write the equation. Negative x squared plus 6x plus 10. And we'll go right through all points really nice. Okay? And then we'll add the x-intercept into it. Why not? Okay? So there's our graph. Sometimes these graphs, a little tricky, but if you put it behind text, it's usually pretty good. We got the graph sketched here, which is big enough. Perfect. And the last thing we have to do is domain and range. Sometimes you want to see the graph. Now, this goes up as high as 19 for the range. Remember, the range is the highest y value, and x size are the same. So I can steal the domain and range here, and I'll just update them for our question here. So I'm going to steal these for a minute. All right. So domain we can write it like this, or we can write it like this. Okay. And the range is y, and this time it was obviously because it's a maximum, so that means it's going to be less than or equal to whatever the x value was, and it was 19, and up as high as 19. And again, we can write this as interval notation, and that would be from minus infinity this time, all the way up to including 19. So we use a square bracket to include 19. So those are equivalent. And you would do those in grade 10, okay? And that's how you sketch your graph through. All right. That's it for example 2. So in the next video, we'll go back and we'll look at the word problem. We'll continue on, I should say, with example 3 and the word problem. Okay. So that's it for me, and we'll talk again soon.